Welcome to the Unit 2 Section 2.2 video. This is going to cover code blocks, the XY coordinates, and pixels. Alright, so first thing we're going to go over are the code blocks inside Scratch. You've probably already seen these. You might have already programmed with them. If you're new to this, we'll quickly go into it. But these blocks inside Scratch connect to each other. It's often described as how Legos connect to one another. I would kind of agree with that. It does get a little complex at times. It's one of the good things about Scratch is that they're easy to connect, and the bad thing is that it does get complex, especially when you get some large programs put together. All right, so let's quickly look at these blocks so you get an idea of what's going on with these. So these are blocks, and you might have seen me connect them in other videos, or other people make them in their videos. So they just kind of click together and do stuff, you know, just whatever it happens to be that you're putting in there. I'm just going to quickly put in some code here. We're just going to make this cat spin around, then go to the mouse pointer. So it's going to spin around 100 times at 15 degrees, then go to the mouse. And you can see there that these blocks just click together like so. There are 6 block types inside of Scratch. The first one over here on the left is your hat block, and it doesn't really look like a, I guess it looks kind of like a hat. But these hat blocks will sit on top of the entire function, and they will be what starts the function. And we'll go through these in a little bit of detail later on. Next are the stack blocks. Stack blocks, they can perform all sorts of different actions. And the main thing to know about stack blocks are blocks of code can fit on top of them or underneath them. And these also can fit inside of some other blocks, which I'll show you. Next are reporter blocks. These are variables, and the variables can store audio information, volume, XY coordinates, or any sort of custom variable information you set up that's global or local. Next are the C blocks, and the C blocks are shaped like a letter C, and these are usually for some sort of logic or some sort of repetitive action. The main thing to understand about C blocks are that inside of them can be other blocks, and you'll probably see a lot of your stack blocks inside of the C blocks. You won't see any hat blocks because hat blocks have to sit on top of the entire function. Next are Boolean blocks, and Boolean blocks are used for logic. You can check for greater than, equal, less than, and you can also use for your and or not logic. So there's a lot of different type of configurations you can use with these Boolean blocks. And you'll notice they're shaped like hexagons. So they will fit inside of a part of a block that's a stack or a C block that will take the hexagon shape. And then finally are the cat blocks. You'll use these probably the least amount. Well, that's hard to say actually. But the cat blocks, they actually stop the functions inside Scratch. And they've gotten very good with the latest updates of Scratch, where they allow you to stop all the functions within a single sprite or a particular function just by itself, or actually the entire program. Let's switch over to Scratch. Whoa, just passed it. There it is. So over here inside Scratch, let's quickly just kind of give you a rundown of some of the different blocks. Your events blocks, this has a lot of the cat blocks. Actually, I think almost all the cat blocks will be within the events, unless you go to the more blocks and create one over here. So the events, these have all your cat blocks, and you notice there's some different ones that perform different type of features based upon if the user is pressing the space key to make something happen. Here's that piece of code I had earlier. So if they press space, it'll make the cat spin around and go to the mouse pointer once it completes the code. This one operates whenever the green flag is clicked, which is this green flag. And then there's just, you know, lots of different types of hat blocks. This one when the sprite is clicked. So if I was clicking around here, this is a good way to make some quick interactivity. You also notice there's some stack blocks down here that have some drop down menu items. We'll go into detail on those later. Then we have our control section. This is another category. You'll notice that we have some different C blocks. The repeat, we have the forever block. This will run things forever. The repeat runs a certain number of times. You can put variables inside this data entry area here. Next, we have some C blocks, and these will take the hexagon shape I was telling you about. If you look right there at that one, that will check for some sort of Boolean logic. And the if else, this will also check for some sort of Boolean logic. Now you notice this one doesn't look like a C, actually it looks like a letter E. Don't let the details confuse you. Just understand that whenever it has these indentions inside the block, you can put pieces of code inside there. So if I wanted to, I could just stick that inside there, and so forth. I can actually put C blocks inside of other C blocks. All right, this code doesn't do anything. I'm just giving you some ideas. Down here is a cat block. And this one was the item I was telling you that can go through and stop all the code wherever you need it to. I don't have any functions set up, so it doesn't really serve quite much of a purpose right now. You'll see right here we actually have a cap block right here within the control category. Next we have the sensing category. Sensing, this will be looking for user input. A term you hear quite a bit in computer programming is listening. So these sensing blocks, they'll be listening for user input. There's quite a bit of reporter and hexagon shapes in here. If you go through, you can see a lot of different block types and kind of figure out what they do just based upon the names of the blocks. Next are operators. This will be all of your operational logic blocks. This is where you can do some mathematics as well. You'll see that we have our addition, subtraction, multiplication, division. We can pick random numbers. There's the greater than, equal, less than, Boolean blocks, and the and, or, not blocks. Then down here we have some other reporter blocks that perform some other advanced features. Here's a fun one. This has a lot of math functions in there for you. So if you need the sine or cosine, which we will use in the future, so you can get some pretty advanced algorithms rolling with Scratch here. More blocks. I'm not going to mess with this too much, just because this gets into a lot of customization of blocks as you create them, and I think that's something you should tackle once you get some exposure to Scratch. Motion. These blocks will control the movement of the sprite. So from here with the motion blocks, you can tell it to move anywhere on the screen that you want to. If I wanted to, I could just come over here and give you an idea. Say we get the forever loop, motion, let's tell the cat to go to the mouse pointer. So the cat's going to go anywhere to the mouse pointer based upon a combination of the blocks over here, with the hat block forever from the control, and then the motion block that tells it to go to the mouse pointer. And you can see over here that we have the ability to set the XY coordinates, which we'll talk about next. Looks. This changes not only the way the sprites look, but also changes some of the I don't know how to put this, but allows you to create these little text displays above the sprites, so that way they kind of look like they're talking to each other. It's kind of a neat feature. It gives you some instant fun whenever you are wanting to start learning Scratch. You'll notice right here also that I double clicked on the function. This will execute the program by double clicking on a hat block. In addition to double clicking on the hat block, I can also just click on the block itself and it will execute it as well. So that's kind of a little trick with Scratch. Now the problem with that is though, say I have this function over here and this, then I click on this block, this will not start this program. So you have to click on the green flag in order for this to take place. Let's see. Then we can also change some special effects here with the looks. Sound. This has a lot of features, actually some pretty advanced features. A lot of them I'm not very good at because I got kicked out of band in the 7th grade, so I'm not somebody you would consider to be musically inclined. However, you can put together some mad beats with this thing and actually program your own music by calculating the beats and the different instruments, as well as getting into the rhythm of how it puts together. I've seen some people put together some pretty complex music. Now, if you're not musically inclined like me, you can actually go up here and choose some of these blocks, such as play sound, and it'll allow you to import MP3 files or WAV files that you can play them within your program. And we'll talk about how to get all those in there later. The pen tool, this is pretty neat. It allows you to draw on the screen and give you some interactivity. If you wanted to, we could say, we can put this right here, then click on start. Then you'll notice I'm able to draw all over the screen with the cat by doing that. Okay, so the pen tools allow you to draw on the screen. There's a lot of different reasons why you would do this, and we'll be using this in some future programs as well. And a very important section called data. This is where you'll make variables and lists. Sorry about that, I had to pause the video there. All the data organized. A variable is going to be a storage container for some sort of data purposes, and whatever it is that you want to use the data for, so you can go out there and manipulate the program, which are called strings. If you want to make a variable, you store those inside here. Variable. Let's just call the variables. They can be used for all sorts of different purposes. A list, most people, a bit more complex than a variable. And the list, and then once you create the variable, going to be a large collection of related data right here. Just imagine your cell phone and you have a list of your contacts. That would be a good example. Okay. Then you'll notice additional blocks show up in that program. The variables have all your contacts by their name, color, phone numbers, and then stored inside your cell phone. That would be a list. Then a variable, that could be all sorts of different items. Primarily, as you'll see in our programs, we use variables to keep scores or how many lives a particular player might have. To create one of these variables, you would just click on the button. Then it gives you an option for all sprites or for the sprite only. We'll also need to type in a name. Let's call it variable. Make sure I spelled that right there. Then click on OK. And then once you create it, all the blocks for the variable will show up here. And the same thing goes for a list. You can just create the list and then the blocks will show up. We'll get into the details of these blocks as we start learning how to program. Moving on, let's go back to our presentation here. Let's look at the XY coordinates for the stage. Whenever we get into our stage, I'll go back to Scratch. Your teacher can show you these slides if you need to take some notes. So we're back here on our stage, and I'm going to hide this and hide that so we don't see it anymore. I'm going to go to my stage, and Scratch is pretty smart, or actually MIT is pretty smart, because they realized that we would use this to teach with, and they came up with a XY coordinate backdrop, and I'm just going to pull that up. So your XY coordinates for Scratch are broken into 4 quadrants. You have your quadrant 1, which is your top right. X is positive, Y is positive. Over here you have your quadrant 2. X is negative, Y is positive. Quadrant 3, X is negative, Y is negative. Then over here in quadrant 4, X is positive and Y is negative. And then the center point of origin for where the X and Y meet at 0, 0. Okay, so that is the XY coordinates and the quadrants for Scratch. Okay, next we're going to get into the XY coordinates of this in the stage. On the x-axis, which are all your points from left to right, there's going to be a range of values from negative 240 to positive 240. So the far left part of the stage is negative 240. The far right part of the stage is positive 240. That's going to be a total range of 480 units across, which are 480 pixels across the Scratch screen. So from negative 240 to positive 240 is 480 individual little steps it takes to get from the far left to the right. The y-axis is going to be from positive 180 up at the top down to negative 180 at the bottom. And that's going to be a total of 360 units from top to bottom. In addition, the coordinates for your objects are going to be the combination of the x and y axis points. Let's go back to Scratch. It's a little easier to explain. So we have our fancy cat right here, and the cat is going to be located at the x of 122 and the y 63. And that is its exact location. Now if you look at the cat here, you can see it's pretty large, and if we were to get into the specifics of its coordinate, you'll notice that the cat actually spans across those points on here. And that's fine. We'll get into the reasons why it's located in more than just one point physically. However, its exact coordinate is based upon a center position that we will choose on the sprite. If we move our cat down here, you'll notice that it changes down to negative x and negative y. And these coordinates will help us understand exactly where our objects are in this XY coordinate grid. Next, for the XY coordinates in the stage, part 3 of 3, if we look at our ratio of X to Y, you'll notice that's 480 by 360. Okay, that's the width by the height. And if we were to break the ratio down, it's actually going to be a ratio of 4 to 3. And that is how the Scratch screen is organized. So you'll be a little bit limited on how large of a screen you can actually make your Scratch games, or how much detail you can get into those images due to the limitations of the ratio of the screen. And one other item on this bullet point list right here, this is important. Every object in Scratch has an XY coordinate except for the stage. I didn't put that there, but you probably read it someplace else. So the only thing that doesn't have an XY coordinate is the stage. If we come back over here to Scratch, like I said, there's the Scratch cat, and it's got an XY coordinate. If I was to put some, more images on here, like some bananas, it's kind of slow. There we go. So the bananas actually have their own XY coordinates as well. If I came over to the stage, you'll notice the stage has no XY coordinates. It would not be programming if we didn't actually start talking about the pixels of our images. And the pixels are very important when we get into two-dimensional programming for games that you would make with Scratch, or maybe with Unity in 2D. So pixels are the little squares that make up the graphic images. If you look over here, you can see that I zoomed in on this fancy little character from Scratch, and I zoomed in on its ear, and you can see that there's little tiny squares there. And these little squares are the pixels. Okay, pixels are mainly the visual points within raster graphics. So anytime we get involved with a raster graphic inside Scratch, you'll primarily think along terms of pixels. However, that's not always the case. If you just go through these points here, you can see that it's a smallest controllable point represented on the screen. Not all pixels are the same size. It depends a lot on your monitor or the graphics card inside your computer. I mean, there's a lot of factors that control the amount of pixels, and some people don't really mind if the pixels are very large, and gets that kind of clunky retro styled look from the 80s with some Atari or old Nintendo Entertainment System type pixelated graphics. The more pixels you fit on your screen, the higher the resolution. I'm sure most of you realize that from seeing all these 4K TVs, or I guess 4K is popular now. I'm sure something's even better coming around the corner. And then the less pixels you fit on your screen, it's going to be a low image resolution because the pixels are very large. And the pixels on the computer usually come in only 3 colors, which is red, green, and blue. And there's a lot of factors as to why it's that way, but we don't want to get into that because it gets into a lot of the physiological aspects of the human eye, and there's some other items with pixels on the computer screen that kind of break the rules of RGB. But for our purposes, we'll be working primarily in RGB. Pixel dimensions are going to measure the width and the height of our sprites. If you look down at our example here, we have the fancy little Scratch cat, and it is 93 by 101. So it's 93 pixels on the X and 101 pixels on the Y. Okay, so that's going to be its dimensions. Over here you can see this backdrop for the stage. It's 480 by 360. That pretty much tells you it's going to take up the entire screen, or the Scratch stage, excuse me. Okay, the maximum width for a sprite is 408 pixels. Maximum height is 360. The minimum width for a sprite is 1 pixel. The minimum height is 1 pixel. And the stage is always going to be 480 by 360. Let's switch back to Scratch here, and if you click on your Scratch cat and come over here to costumes, you'll notice right there are the different pixel dimensions for the different costumes for this particular sprite. If I came over here to bananas, you'll notice that it has a dimension of 78 by 76. Now if you were to come in and get the image and say make it larger, you'll notice that the dimensions instantly change. However, this can also be a trick, and watch this. So I'll have the image selected with this one. I'll change the color here. I don't know if this will work. There we go. We'll change the bananas to black. I guess they've been sitting out in the sun too long. So I'll come up here to this tool, which is the shrink, and I'll start shrinking it down. And you'll notice it's very, very, very small. Okay, but look at its pixel dimensions. It's still the large size dimensions that we had originally made when we dragged out the image to get it larger. So these grow and shrink tools, they're pretty handy, but in the end I think they're going to cause more harm than good, because the dimensions of this particular costume are still 242 by 236, even though on the screen it's probably taking up about 25 by 25 pixels or something within those ratios. That will wrap it up for Unit 2, Section 2.2. Before we go, quickly just to show you the stage on the backdrop, and you'll notice that its XY coordinates, or excuse me, the dimensions for the backdrop and its pixels is 480 by 360, so you know that that's going to take up the entire screen. However, some interesting things are, if you say we're going to draw one, I'll show you how to draw later on, but if I was to draw, say, just a quick little rectangle here, okay, that's all I drew on the screen, you'll notice that the dimensions are automatically listed as 480 by 360. So it's automatically going to make sure that the dimensions for the backdrop will take up the entire screen. And if you wanted to, you could also say this button right here draws sprites. I'll go over that in some more detail as well. If I was to draw a sprite that completely takes up the entire canvas, and I come back over here, you'll notice it start off as 1 by 1. As soon as Scratch updates, it'll take up 40 by 360 on the stage. Just give it a second here. It's taking a while to get all the graphics to render. There we go. Okay, so you'll notice also that a sprite can take up the entire stage area as well, but your sprite can move around, whereas the stage cannot. So you can have a very large sprite that takes up the entire stage area, but it can also be moved out to the side. Okay, that's a little bit advanced, but I figured it's worth showing you since you're here watching the video. Thanks a lot for watching, and see you in the next video.